Welcome to the CopperSpice YouTube channel, and thanks for joining us. In this video, we are going to discuss inline namespaces and why you may want to use them. Inline namespace. In order to talk about an inline namespace, we should first review the properties of an ordinary namespace, define a global namespace, and then explain how the using directive affects scoping and visibility of a class or method. Once we have the terminology established, showing an example of an inline namespace will be the most effective way to illustrate how it is used.
In order to understand namespaces, we need to briefly explain the term identifier, which is used in several different programming languages. An identifier is the literal name for a class, function, or variable. Reserved keywords cannot be used as identifiers. Identifiers are used to identify a particular program element in your code. The region of code in which a specific identifier is visible or usable is called the scope of the identifier. A namespace is simply a designated block of code. Any identifier that is declared in this block automatically has the namespace name prepended. This marks each identifier in the namespace as being part of a single logical unit. Placing related identifiers in a namespace improves readability and makes the relationship between them explicit. Making sure that unrelated code is in a different namespace helps prevent name collisions. Within the body of a namespace, you can refer to any other identifier in that namespace without any sort of qualification. In order to refer to an identifier which is not in your current namespace, you will need to qualify the identifier by adding a prefix. Although the terms scope and visibility are often used interchangeably, in C++ they have very different meanings. Understanding the scope of an identifier is fundamental in order to use a namespace properly. So what is the scope of a declaration? A scope is a particular region of source code where a given identifier can be used. For example, a local variable is in scope from the point of declaration to the end of the block. A class member is in scope throughout the entire body of the class declaration. Be aware there are a few minor exceptions to this last rule, however they are unusual corner cases. Another example is a file local static, which would be in scope from the declaration all the way to the end of the file. So if a function declares a variable named size, this identifier can only be referred to within the body of the function. The variable size has local scope. The visibility of an identifier is completely different. Visibility is defined by the public, protected, or private specifier when declaring a member of a class or struct. Visibility only matters when an identifier is in scope. An identifier which is not in scope cannot be used at all, so it doesn't even make sense to ask whether it is visible. Calling a function before it is declared is a compiler error. You will usually see an error message saying, "There is no matching function in scope." If you try to call a private method outside of the class it belongs to, the compiler will instead return an error saying that method is not visible. In C++, there is a special namespace which always exists, which you do not add, nor can you remove it from your application. It is a single namespace called the global namespace, which is the root of all other namespaces and identifiers. Every identifier you declare is either in the global namespace or some child namespace. It is very important to understand that just because something is declared in the global namespace, this does not mean it is in scope everywhere in your program or in every translation unit. For example, if you have a function declared in a header file located in the global namespace, that header file must be included elsewhere for the function to be in scope. When an identifier is declared outside of any class, function, or namespace, It is placed in the global namespace. The global namespace has no name, but you can explicitly refer to an identifier in the global namespace by prepending : to the name. Scope, visibility, and namespaces are three completely separate issues. In order for a particular identifier to be usable, it must be in scope, visible, and qualified correctly so it can be found. In this example, calling foo with the prefix : forces the compiler to search only in the global namespace for this function. If there is no function named foo in the global namespace, this call will fail. Without the : the search for a version of foo starts in the current namespace. If nothing is found, the search moves up to the next outer namespace and continues until a match is found.
When using namespaces, there is usually more than one way to refer to the same identifier. In this example, we have a function called swim, declared in a namespace called ocean, which is nested inside another namespace called animal. The first call to swim uses a fully qualified name. The term fully qualified is only mentioned one time in the C++ standard. Our understanding of this term is that the fully qualified name must start with a : to indicate the search for this identifier has to start in the global namespace. The second call to swim uses an unqualified name. The using directive has added the namespace animal : ocean into the search path. The search for swim will start in the current namespace, which is the global namespace. Since nothing will be found, the compiler will then search in the animal : ocean namespace. If swim had not been in either namespace, you will get a compile error. In this second namespace example, we have added a using directive inside of the namespace myLibrary. The code on lines A and B work as expected, since there are qualifications before the function name seed. The code on line C will call the function seed in the v2 namespace, but only because of the added using declaration. Without the using statement, the code on line C does not compile. There is an interesting situation which occurs if the function seed is a template. For this case, a specialization of the template would need to appear inside the v1 or v2 namespaces. If you try to put a template specialization in myLibrary, but not located inside v1 or v2, you will get a compile error. In order to provide a specialization of a template, the code must be located in the namespace it was originally declared in. Clang would report this error as no function template matches function template specialization for seed. There's a problem with this code since it lacks flexibility for a library and may not work properly when the functions are templates. There is also an issue in the code when you have function calls which require argument-dependent lookup, since ADL does not follow using directives. So how can we enhance this code and make it more generalized to handle more cases? So here is our example of an inline namespace. The code is the same as the last example, except the using directive has been removed, and the keyword inline was added preceding the v2 namespace declaration. The code on lines A and B still work as expected, since they are qualified, just as before. The code on line C will call the function seed located in the v2 namespace because of the addition of the inline keyword. When the developers of this library release their next version, the API can be changed without breaking the ABI. The inline keyword will be moved to a new v3 namespace and taken off the v2 namespace. This will allow users of the library to explicitly call one of the older versions of seed if necessary, while having any unqualified calls to seed resolve automatically to the new version in the v3 namespace. If a developer chooses not to recompile their application and just distribute the new version of my library, the v2 implementation of seed will be called since there was no break in the ABI. The symbol name of seed is based on the version of my library your code was compiled with. Even though your application is now distributed with the new library, which has v3, your application refers to the v2 symbol for calling seed.
So the objective of an inline namespace is to preserve binary compatibility in the symbols the compiler generates across library versions. As the user of a shared library, you may want to update for some improved functionality or a bug fix. Distributing the new shared library version without recompiling your application works as long as the library did not break ABI. Your program will happily continue to call the v2 version of seed, even though the library contains a v3 version. For all of this to work properly, the mangling of identifiers in namespace v2 needs to remain the same when the inline is moved from v2 and placed on the new v3 namespace. This is a great feature for users of a library if the developer is willing to use an inline namespace properly and is able to offer a stable ABI. As a library developer, you need to consider if maintaining a stable ABI is a good direction. The choice to support a stable ABI may not always be the best option for a rapidly evolving library, since it reduces flexibility.
There is another benefit to inline namespaces when you consider things as complicated as the C++ standard library. The addition of inline namespaces allows standard library developers the ability to provide ABI versions for something as fundamental as std::vector. A new version of the standard library can provide support for ranges or concepts when the appropriate compiler options are passed. The idea is to keep the ABI support for applications using older standards like C++11, all in one library. There are platform-specific linkers which do provide a feature called symbol versioning. This has been used in the past to accomplish what an inline namespace can now do. Symbol versioning was hard to maintain and depended on compiler internals. With inline namespaces, there is now a clean way to provide multiple ABI versions in a single library, using only standard C++ code and no platform-specific features. Inline namespaces have been a somewhat unknown feature, and if you are a library developer, we encourage you to consider using them.
For more information on the CopperSpice project, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us email.
Please make sure you subscribe to our YouTube channel and come back in a few weeks for our next video.